This video is another CenCon interface introduction. This particular unit is configured for single volume and indirect fired makeup air with packaged cooling, our FW-DJ series. At the very top, right here, we have our discharge air temperature readout, just below our outside air temperature readout, heating demand, cooling demand. If your unit was configured for it, here you would see your VFD feedback and your damper position. This particular configuration is a 2-position damper, being a makeup air, so it's either 0 or 100% open. Down below, we have our discharge air set point. This is adjustable by just clicking on it. Inside, you can type whatever your desired set point to be and hit enter. That will change your discharge air set point. This is where you could change your VFD minimum speed if we were configured for this, and your minimum outdoor air damper minimum position as well. On the bottom, we have what mode we're in and the status of the unit if there's any alarms. Over here on the right, we have some identifiers. ENF is our enable fan. That is an input to the CenCon to turn the unit on. SA is your supply air. It's an output from the CenCon to turn the supply air fan on. DM is our damper motor. This is an output from the CenCon to our damper motor. And OCC is occupied. It's an input to the CenCon letting you know that we are in occupied mode. Now if we tab over to the right to the JXM page, on the top section here we're going to see again our discharge air temperature readout, outside air temp, our heating set point, and our current heating demand. In the section below we have our exchanger warm-up time, which is 75 seconds if the ambient temperature is below 40 Fahrenheit and the discharge air temperature is less than 90 Fahrenheit. Both of our cooldown timers are 90 seconds. Pre-purge timer is 1 minute. Our trial for ignition timer is 1 minute. And our maintain purge timer is 5 minutes. At the very bottom section here, it is a unit status to let you know where in the ignition attempt range we are at. Number 1 is move to purge. Number 2 is purge. 3 is move to ignition. 4 is ignition attempt. 5 is main valve and burner on. 6 is post purge. And 7 is shutdown. Now if we move to the top here, we have RPM demand and RPM feedback. Our RPM feedback always needs to be within 5% of our RPM demand, or we will get a RPM out of range alarm. When you get that alarm, you can always look at your speed sensor or your magnet or anything like that for troubleshooting. Just below here we have our ball valve voltage and our ball valve feedback. This is your modulating valve and the position it's at. At the bottom of the page we have our ENH contact, which is our enable heat, which is an input. The pilot valve is an output to our pilot valve. FR is for flame relay. It's an output to our ignition control. SR is safety relay. It's internal contacts to the board that look for various safety sequences that have passed, and once they have passed, it energizes and allows the burner to light. FPV is our valve feedback, lets you know the main valves have opened and your burner is on. And HL is our high limit alarm. Next, we will tab over to right here, the ball valve calibration page. Now, this page is for if you ever have to replace a ball valve, you have to come in here and do a new ball valve setup, or if, for example, you had a gas valve out of range alarm and you were concerned the setup was not done correctly, you could come here and do another setup and make sure everything's set properly. So the first thing you're going to do is this Start Setup button up here. You're going to click it, and you can see we're going to go to the first one where the gas valve is closed. This gas valve is a 2 to 10. And after the gas valve has moved to its directed position, if it were out by 0.1 of a volt or whatever it might be, you can enter it on the right here to make sure that we're reading exactly where the ball valve is. And you would continue on down the line through all the various steps at low fire, near low fire, medium fire 1, 2, near high, and high fire. So here we're asking the valve to go to 2 volts. The valve is actually going to 1.9. You can enter this up here. Enter 1.91 as it states where the feedback is. Hit enter, and that's complete. And then you would move to low fire, and so on until your setup is complete. This one, as you can see, the setup has already been done. You go one by one all the way down to get the green light, and after the setup's complete, you can unclick the Start Setup button, and away you go. Okay, next we will go to the JXM Combustion page. Now, on this page is where we can perform a combustion analysis of the unit. At the top here, you have your service mode button. Right below it is your time elapsed, and it will start counting up, letting you know how long you have been in service mode. After 1 hour, this will time out as a safety precaution to pull you out of service mode if you have left it in there. Right below here, we have our service override. This is a percentage, and will put you into the various firing rates you need to be in, 100%, 90, 55, and so on, to do a full combustion analysis of the unit in all its ranges. Just below that is our discharge air temperature. This is a good thing to monitor while you're doing combustion analysis, as it can get quite hot and you don't want to trip the high limit or cause any problems down in the space. Over on the right, we have our RPM demand and our RPM feedback. This is where your combustion air fan is at during its operation. And just below is your ball valve voltage and your ball valve feedback, and this is your modulating valve, letting you know the position it's in this current operation. Now, I will quickly take you through a brief overview of how to do a combustion analysis. We will go through this more detailed in a later video, but I will give you a quick preview of what needs to be done. So first, we will click the service mode button. You can see the counter has begun timing, and 4% is low fire, as you can see down here. So you've already probably noticed that our RPM demand and our ball valve voltages are dropping into low fire. Now, when doing a combustion analysis, the first thing you want to do is high fire. So we're going to type in 100% and hit enter, and you will see RPM demand, and our ball valve is now rising. Ball valves are opening, our fan is ramping up. Everything should be going to high fire. Now, when we get to high fire, you'll need your combustion analyzer. You're going to have to be taking your oxygen and your CO readings and making sure everything's okay. At high fire, our oxygen will be adjusted by our Pac-Man slider physically on the combustion air fan itself. If you needed to decrease or increase oxygen, it should be done by the slider there, not the air offset. The gas offset here should go to your full open, around to 9 to 10 volts there. If you needed to decrease or increase gas, you could do it here, but that should also be set at our internal regulator by looking at manifold pressure. So the next sequence we're going to do for combustion analysis, after you do high fire and you have that set with the slider and your regulator and your manifold pressure, we want to then go down to low fire and work our way all the way back up the ladder. So we're going to click here. We're going to go down to 4%, to go into low fire, we can see everything is dropping, valves are closing, RPM demand is dropping, our fan is slowing down. Now, when we get into low fire, you can now use these air offsets and use these gas offsets to set your combustion. So what we would do once the fan settles in here, if you needed to increase your oxygen, you would click here. Factory default is always 0. If you want to increase it, you can just hit 1 and hit enter, and that will slowly speed up your fan, as well as your gas. If you wanted to increase it, you can start at 1 and hit enter and increase it. Once we settle in here, you'll see where the RPM demand is at, and I'll show you how it increases incrementally from low fire as you set these offsets. So our RPM demand is at 1020. It is settled in. So again, if you wanted to increase this still further at this point, you can type in 3 and hit enter. You can see the RPM demand went from 1020 to 1088. Obviously, you're going to be taking your combustion air readings and making sure everything's okay, and vice versa. If you needed to decrease it, we can go into the negatives. You can go -2. And you can see your RPM demand dropped all the way down to 918. Your gas valve works the exact same way. We can increase it to 5. You see it went from 3.4 to 3.8. We can decrease it down to -3, for example, and the gas valve will begin to close. And you're down at 3.0 volts now. One thing to note that is very important, as you move from low fire to near low to medium 1 to medium 2 to near high, is that you increase everything incrementally. And what I mean by that is, if you now move to near low fire, and after everything's been set up, your RPM demand is 1000. When you go to medium fire 1, it's very important that your RPM doesn't dip below the 1000 that was at near low fire. You want that curve to keep increasing incrementally. Same with your gas curve. We want it to keep going up incrementally. We don't want you to have 3 volts at near low fire and then 2.8 at medium fire 1. This will cause poor combustion values, but also control issues with our controller. So it's very good to keep in mind that we just want to keep increasing this incrementally throughout. I should note that if you're going to perform a combustion analysis, you need to be a qualified tech with the proper tools like a manometer and a combustion analysis and a combustion analyzer to get this done. Also, once you have completed all this and your combustion is completely set and all your numbers are set here, the next thing you're going to want to do is tab way over here to the right to the Save and Load page. And once you get to the Save and Load page, there's a Save Settings button down here in the bottom. You're going to want to click that, and then it will save all your combustion settings. So, which is very important. If you cycle the unit off without doing that, it would reset everything back to its factory default. Now, next, if you tab to the right again, we have our CXM page. Now, this is our cooling page. On the top here, you can see, again, your discharge air temperature readout, outside air temperature, and what your cooling, your current cooling demand would be. At the very bottom, status 1, 2, 3, 4, 5, 6. This is the stages of cooling that you would have on. These would be illuminated for whichever stages of cooling we're currently engaged. On the back to the top here is your ambient lockout, which is adjustable. This is where you can have your cooling lockout below whatever temperature you want to set it to. So you can set it to 55, and your cooling will be locked out below 55 degrees. The lights here, ENC is your enable cooling. This is an input to the CenCon board to enable our cooling. Both of these down here are ambient controlled condenser fan stages, but are programmed into the CenCon. We tab over to the right again. We have our CXM service page. Now, this is very similar to the other service page. You have your service mode button here. You turn that on, and your time elapsed again will start counting up just like before, and will take you out of service mode within 1 hour as a safety precaution. So here you can control what compressor stages you want to run by turning them on and off. You have a min run timer, which is 5 minutes, and a min off timer, which is 5 minutes, just as interstage timing, and it's fairly straightforward. So doing a startup or a compressor change or anything you need to do, you can come into this page and control which compressors that you want to run. Next, we will go to the alarm page. Here on the alarm page, we're going to display what alarms may have come up, whether they're heating, cooling, or communication alarms. And you have your alarm reset button right here. So for example, we just went into a high limit trip. It tells you that's a heating alarm. And the way to reset it is you can do an alarm reset right here at this button, or you can cycle power at the service switch, and that will also reset any alarms you get. If you ever get a communication alarm, it'll say module offline. Usually that's going to be your Modbus wiring or communication between the CenCon to each of its expansion modules. And the final page is your save and load page. You can change your minimum and maximum discharge air set points from a minimum of 50 to a max of 130 there, and on the maximum you can go to a minimum of 55 to a max of 135. You can also change your outside air damper minimum volts. This is a 2 to 10 volt damper. If you ever needed to make any adjustments to its opening, you can do it here. And so any changes you make, whether it's to the ball valve calibration or the combustion, or in this page right here, once you're done any of that, you'll need to come back and click save. So all your settings have been saved, and when you cycle power and turn it back on, everything should be as you left it. Now we can go back to our main page, and that concludes our video for today. If you want any further information, please refer to our CenCon technical manual, or you can call our technical support team. Thank you for your attention.